All right, trying to figure out what translation maps triangle ABC to triangle DEF. So if we map A to D, we have to go to the right one, down 3. In fact, that same translation works for all of them. So that's a translation to the right one, down 3. Translation along the vector 1, -3. This one, it should have been a negative here. So if the only thing that changes is the y-coordinate, then that's a reflection across the x-axis. All right, so if we plot point A at -2, 1, and then plot the point A prime at -2, -1. Sorry, that was A. A prime at -2, -1. Hopefully you see that it reflects across this x-axis. Number 3, reflecting across the y-axis. The only thing that's going to change is the x-coordinate, the sign on the x-coordinate. We're translating each point along the vector -2, +1. So you can add -2 to the x-coordinate and 1 to the y-coordinate. So A prime will be -5, -4. B prime, -3, -3. And C prime, -4, +3. You could also graph it and move each point to the left 2, up 1, and then write the coordinates down. Number 5, we want to describe the transformation. So if the one on the right is the original, then we're reflecting it across this y-axis. Notice that the A is 1 unit to the right, A prime is 1 unit to the left. Same thing for B, 3 units to the right, B prime's 3 units to the left, and it works for all those points, so it's a reflection across the y-axis. Number 6, we're translating, we're going to write a translation in words for this. So A gets moved to the right 1, 2, 3, 4, and then down 1. So right 4, down 1. We can make sure that that works for the B to the right 1, 2, 3, 4, down 1, and sure enough it works. So in words we can say it's translated to the right 4 units, down 1 unit. Here we want to graph the line y equals 1. So everywhere you go on this line, y is 1, x can be anything we want. Plot those points. So we start to see this horizontal line forming. This is our line of reflection. All right, so R is right on top of it, so reflected R prime is still right there. P is 3 units above, P prime will be 3 units below. And Q is 2 units above, Q prime will be 2 units below. Number 7, we're reflecting across the line y equals x. At least 2 different ways to think through this. One is to make a little xy chart. X and y must be equal. So you could have 0, 0, 1, 1, 2, 2, and so on. The other way to think through it is y equals 1x plus 0. Your slope is 1 over 1. Y-intercept is 0. So plot a point at the origin, rise 1, run 1. Either way, you should be getting this line here. Point A is on top of it, so A prime will be right there. C is kind of like one diagonal unit away from it, so on the other side, one diagonal unit. And then B is kind of two diagonal units away, so two diagonal units away, be right here. If you want to look at the coordinates, what ends up happening for each of these points is you swap the x for the y and the y for the x. So the original A is 1, 1. Under this transformation, the reflection across the line y equals x. The x and the y values swap spots. So A prime still 1, 1. The original coordinates for B is negative 1, 3. So the new coordinates for B or B prime will be 3, negative 1. And then C, the original coordinates negative 1, 1. And C prime 1, negative 1. So if you want to memorize that rule, you can memorize that. For reflection across the line y equals x, swap the x for the y. Here we're reflecting across the y-axis. So across this line, the original C is 1 unit to the right, so the C prime will be 1 unit to the left. The original B is 3 units to the left, so B prime will be 3 units to the right. Original A is 2 units to the left, so A prime will be 2 units to the right. Here we're translating each point to the right 3, and then down 2. So A prime will be there, B prime to the right 3, down 2. C prime to the right 3, down 2. Is this the rigid motion? No, because it changes size. For a rigid motion, it must keep its same shape and same size, or we could say same lengths and same angles. So on this one, the lengths change. You've got a side length of 3 here, and it looks like 1.5 here. How many lines of symmetry? All right, so we could reflect it across that line. It would land on top of itself, map on top of itself. That line. Trying to go from midpoint to midpoint there. All right, so if you count all those up, you get 6. For this isosceles trapezoid, just right down the middle will work. So just 1. The parallelogram here, some people thought maybe this diagonal, but then this point ends up being about right here, if those are congruent and perpendicular to that line. So it does not match up, so 0 lines. And then for this isosceles triangle, 1 line. you may remember from all the problems we've done, regular polygons, meaning all the same, all the sides are congruent and all the angles are congruent, will have the same number as the sides in that, which, glad I thought of that because this is wrong. Should be 8 here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yes. All right, so 8 lines of symmetry. We want to rotate 90 degrees about the origin. Right now we are in quadrant 4. So if we go 90 degrees about the origin, we're going to land in quadrant 1. A will map to that point. B will map to there. And C prime up here. It's a rigid motion, so we're going to end up with a right triangle with legs of size 1 and 2, just like we had at the beginning. If we form an angle between A, the origin, and A prime, we should be looking at a right angle. Same thing if we're looking from B to the origin and then B prime. Should be a right angle there. And same thing for C. We're rotating 180 degrees about the origin, so right now this triangle's in quadrants 3 and 4 as well as the positive x-axis. So when we rotate these, we'll be in 1 and 2. The point B rotated 180 degrees about the origin will be here at -1, 0. Point C rotated 180 degrees would put us at 1, -1. And then the point A is on the y-axis, so A will map to 180 degrees will be +3. 0, +3, I should say. So if we connect those points, so this triangle should be congruent to the other one, same shape and same size. Just if it helps y'all, go ahead and erase that so that you can maybe more clearly see the final answer. #15. This appears to be a reflection here, and then another reflection. So when we look at just from the first to the third, it does appear to be a translation. We can just go up however many units. So all of these are along the same vector. So yes, the third image is a translated image of the first. Anytime you reflect an object across two parallel lines, then you could accomplish that movement from the first to the final image through a translation. But it's only if it's a reflection followed by another reflection across parallel lines. And they tell us up here that the lines are in fact parallel. All right, 15, glide reflection from ABC to triangle DEF. You're going to reflect it first. So let's see, if we just reflect point A across this line, y equals 4. B and C are already on there, so they'll stay in the same position, and then we could do a translation to the left 1, 2, 3, 4, 5, 6 units. Left 1, 2, 3, 4, 5, 6 units. So each of these points translated to left 6 units. All right, so first we saw a reflection across the line y equals 4, and then that was followed by a translation to the left 6 units. Remember, when you write the composition of rigid motions, or you could say composition of congruence transformation, when you're putting more than one of those together with a composition, you use this little 0, or O I should say, and then the one on the right comes first and then the one on the left. So the reflection happened first, then the translation to the left 6 units. All right, so hopefully this better prepares you for the next test.